Well, it was October 23, 2020, about 2 years ago now, that one rainy, cold weekend, I decided that I was going to try and write my favorite game from my childhood, Lemmings. If you remember it, then you'll be similar age to me. Those were simpler times. It was on the Amiga, and I thought, can this be done using Canvas apps and Power Effects? And then shortly after I started, I realized that it could. And I tweeted, we said it couldn't be done without PCF. Well, we were wrong. So in this episode, stick around and I'll show you how I did it and the kind of problems and challenges that I encountered. It was Ignite on tour in London when I was talking to Clay Wiesner, who was leading up the Power Apps, Canvas Apps team at that time. And I was telling him about the fact that whenever I learn a new language, I try and write Lemmings using that language. There had been various different low-code languages before Canvas Apps. There was one called Touch Develop that I remember trying to write Lemmings in. It was low-code before even low-code was a thing. Sadly, it's no longer around. And the thing about Lemmings is this environment where you've got all of these little lemmings interacting with both the environment they're in, so walking across the land in a pixel perfect way, walking up hills, but also interacting with each other. So you can have blocker lemmings that stop other lemmings from going past and they change direction, but also interacting by digging and building blocks and things like that. And so it doesn't matter where the lemmings are, they have to follow the same behavior. And they're all interacting all on the screen at the same time. So there's lots of nice challenges. It lends itself very much to an object-orientated way of thinking. And so that's why I like it from a programming challenge standpoint. We were talking about it, and I think we came to the conclusion that we would have to build it using some kind of code components. In business and in enterprise applications, the fact that you can use a PCF, a code component, is actually a benefit because it allows you to solve a problem if you can't do it using load code tools. But for this particular challenge, I wanted to prove that you could do it purely using a low code language like PowerFX. So on that rainy weekend, when I started to think about it, I divided up into some challenges that I thought I'd tackle in order. And I started with perhaps the thing that I thought was probably going to be the most complex. As it turned out, it wasn't, but it was sprites. I had worked on ports of Lemmings in other languages before, so I had some of the assets. If you go into Google and you type Lemmings sprites, you get a whole load of images. And if you look for Lemmings, you'll also see people have ported it to various different languages as well. So you can see there's actually an Amiga emulator. There's various different instances that you can play online. There's also a DHTML version, which is DHTML is such an outdated term, but it's a JavaScript implementation. So there's lots of resources that you can draw on to understand the logic. One of the things that Lemmings does is that it has, obviously, the graphics are very pixelated because when it was originally on an Amiga, the Amiga was very good at managing sprites. It wasn't very good at managing lots and lots of sprites. So the hardware had the ability to, it's called bit blitting, a way of copying data into graphics memory and then moving it around very fast without affecting the background. With sprites, what you're trying to do is you're trying to animate sprites. Now, the first thing I started doing is I thought, okay, well, let's use an animated GIF because animated GIFs are great. You can just simply pop them on a design surface inside a canvas and they will increment their frames and they will just, you don't have to worry about them. You can just leave them and forget and they'll animate. Now, the challenge with that, of course, is that in a game like Lemmings, the animations have to be completely synchronized with the game progress. You can't just have an animated GIF just doing its thing. You need to make sure it's doing advancing the frames in a very specific order. And the thing about an animated GIF, you can't reset those frames. So you can't say restart that animation. It's always going to start the animation as soon as it has actually rendered, and it's always going to repeat. So quite quickly, I discounted that idea. It's great for animating just sort of other icons, like in Lemmings, you have the tools that you can select across the bottom, and that's more decorative. So that's great. But for the actual gameplay, GIFs, animated GIFs just weren't going to cut it. So if you look at the assets you can find on the internet for Lemmings, you can see that you've got a very long image, a sprite map, if you like. In that sprite map, you've got many, many different frames. And so if you think about how you want to render these images, really what you're looking at doing is clipping the image, so it only shows the proportion of that sprite map that you're interested in. One of the elements that was fairly new at the time inside Canvas apps was the container control. And actually, when you render the container control, if you look at the HTML that's admitted inside the Power Apps when it's rendered in the browser, it's just a div. And any elements inside that div have coordinates relative to the position of the div. And so what you end up with doing is, if you put an image inside of that container and then you change the offset of that image so that it only will show you a proportion of that image, then you'll start to get that animation effect. So by assigning a variable to the X coordinate of our image, what we can do is we can just simply advance that X in the frame size, and each time you advance it, it will advance the animation on. So this is great. So this was the approach that I decided to take. I didn't find any other way of clipping images. What I did then is that the next step was to say, well, how do we have lots and lots of these Lemmings? Because the thing about Lemmings is that that's what makes the gameplay so exciting, is that you've got lots of Lemmings doing lots of different things, and you've got to look at all these different places. You've got to look at, okay, well, we've got Lemmings climbing up a hill here, and they're going to drop off the edge, and so we need to go and add an umbrella skill to that Lemming so that it can float down. And we've got a load of Lemmings all heading towards another cliff here, so we want to put a blocker Lemming so that it turns them all round. And so you're adding these skills and trying to keep track of what's going on. And so that was the next challenge. So how do we manage having all of these Lemmings inside our environment? Well, the first way I tried it was a very common technique using a gallery. And a gallery, you can actually have many, many different items in a collection bound to that gallery. And rather than having the items just spread out vertically or horizontally, different depending on which type of gallery you use, you can put the template size to be 0. So there's a 0 width. And that means that all of the items are going to effectively be stacked on top of each other. They're going to just overlap with each other. And then by applying an X and a Y offset to each of these images, well, the container that contains the images, that then allows you to move those sprites around in a particular area. And then you can add more and more sprites by just simply adding them to that container. Well, this is great, but so I did some tests, and I added those sprites into a collection and started to move them around on top of a background using the Lemmings background, one of the maps that for the first level. And you can quite quickly see that you start to get flicker. And flicker is something you just do not want in a game. In video games today, there's many, many different techniques to prevent this kind of flicker. It's, you've got hardware acceleration, you've got graphics cards that do a lot of this stuff for you. But we're trying to work out a low code way of doing this. I had to just basically, discard this option. So the next option was another common technique, is by using a image with an SVG. And SVG stands for Scalar Vector Graphics. This is quite promising because Scalar Vector Graphics is great. You can just draw whatever you want. That's what we want to be able to do, is draw different sprites in lots of different places. Now, normally an SVG if you want to put a image inside of that, you would need to provide a HTTP address to go and grab that image from. But of course, we don't want to have to store all of these images somewhere. We don't want to have to host them on a web server. We want to be able to actually embed them inside our apps. And so we've got all of these images for the sprites inside our Canvas app. I started to look at how can we embed that data inside our SVG. Well, as it turns out, you can convert a media image inside Power Apps into a string using the JSON function and making sure that you will encode the binary data. And what that does is it outputs the encoded data URL that you can use to actually create an image inside an SVG. So I did a quick test. I said, right, okay, let's have all of this data URI inside our SVG. And then by using a collection, we can then iterate over that collection and concatenate lots and lots of images together using these images, and then just place them at different XY positions. And using a SVG view box allowed me to do a very similar technique to the container, to clip things together. And this seemed to be really quite performant. I seemed to be able to add quite a number of different sprites. It seemed to be allowed me to add 50 of these lemmings and be able to move them around with zero flicker, which is great. However, as soon as I got over that hurdle, I was sort of rejoicing, but then I suddenly realized that to make this game work, what you have to do is you have to be able to select a lemming. You have to be able to say, I want to pick that particular lemming there and apply this skill to it. Suddenly I was in a blocker because the SVG is just a single object as far as Canvas Apps is concerned. There is no event that I can hook into inside that SVG. There's no on-click event that I can hook into of these elements that are being rendered. Inside the gallery, of course, each of these items were being rendered as a container, and I could have the on-select event of my image very easily, and I could just respond to that. So that would work, but it flickered. With the SVG, it didn't flicker, but I had no on-click event. So I had to work out a different way of moving forwards. And so where I ended up is actually having just simply a brute force approach, just simply having lots and lots of containers that are bound to different sprites in the index of the collection of sprites. And what I was doing is then just simply creating a whole load of images and just picking out that, well, that image will be bound to the first lemming, this image will be bound to the second lemming, this will be for the third lemming, and so on and so forth. So it kind of seemed a bit dirty from a programming perspective, but actually from a performance perspective, it worked. And then the advantage is that it allowed me to have that on select event. I could just click on it and I could respond to the event. Now, what it did mean is that I would have to limit the number of possible total lemmings I had. I created 20 instances and the performance was pretty good. So after I'd got over that hurdle, that was kind of encouraging. It took me all day, and I was pretty shattered after that, having got to the point where at least I had some pretty good animation going on and I'd solved the majority of the problems. And the last thing I added was a little target selector, so I could prove that I could select a lemming and it would follow the lemming around. So one of the other challenges that then presents itself is like, how do you have a way of making sure that this lemming will move up and down the scene that it's in? So, you know, the map, as they're moving up and down on the map, what we had to be able to do is easily detect where the map was. Now, the map had a black background, but we couldn't really use the fact that the map was an image, because there's no way in PowerFX to look at an image and look at a particular pixel in that image and determine the color of that pixel. That just doesn't exist. Really, we don't want the image to really be coupled at all to the way in which our lemming moves up and down in that surface, because The image really is just for making it look nice. There's going to be, grass, and there's going to be various different things on there, and even animated elements which have nothing to do with gameplay. But what we do need to know is we need to know what is land, what is lava or boiling water that's going to kill the lemming, what is metal that they can't dig down under, and where the exit is. So there's all these different parts of the landscape that we need to understand. So we've got the image that looks nice that the user sees, but then what we've got is we've also got a single image of just the information that's needed to understand the behavior of the lemming. Now, if you look at this particular part, what that ends up being is a set of bits which define the behavior of the lemming that's going to be in that area. And so here we've got the green bits are the land, and then that purple bit is the exit. So we know, well, when the lemming hits that particular part of the landscape and it detects that type of pixel, we know that it's the exit. And of course, the same would apply for other types of pixels, like, hitting some lava. And so we can then just, on top of that, put other elements, like, pretty elements. Like here, we've got the exit with all the different animated elements that have nothing to do with collision detection. So what I had to do is to write a routine to first take that data and convert it into a big string, which we could then load into our Canvas app. And so what this is just a big long string with each character representing one of those pixels. And so you can see here the zeros will be the background where the lemmings can walk, and then ones are just simply land. And if you look further down, there'd be a different number which would indicate the exit. And if there was any lava, another different number. And then each level has got a width and a height. So the number of rows, the number of columns in this bitmap image. And what this allows us to do is, based on the X and the Y position of our lemming, we can use a mid formula. So the mid formula allows us to index a big long string based on the start position and then a certain number of characters. So in order to find the bit at a particular XY position, we would take the Y and we'd multiply it by the number of bits in each of the rows. And then we would then add on the X position to get that particular pixel. And then we use mid to grab it, and then we just have a length of 1. So that now gives us the ability to understand what's going on in each of these different pixels as the lemmings are moving. Now, each of the different skills has got a certain behavior, and effectively what it means is that you've got, if you are walking, or if you are climbing, or if you're digging, then what happens is that as the animation ticks along, so there's a game loop that is constantly incrementing the animation and performing a set of tasks on all the various different lemmings. What it's looking at is based on the current position and also the bits around it, it will then move the X and the Y up or down. And indeed, if you are walking towards the right and you look ahead on the map a number of pixels, if it hits a wall, it will turn the direction and it will change the behavior to start walking in a different direction. So what you end up having is all of this behavior dependent on the current animation, the current skill and behavior of the lemmings, constantly looking up the position in the map to decide on what it needs to do. So once I'd got that functionality, and I'd found that actually using the mid string functionality on that big long string, that level map, was actually very efficient. I could very quickly determine what value was at a particular bit without having to worry about any multi-dimensional arrays, because I did initially think, well, maybe I could just use an array of rows and columns, but the indexing of that using, the index function, or back then we didn't have the index function, we'd have to use first and last n to index it, was very slow. So I found that the fastest way was using this string. Now, the advantage with the string also was that I could very quickly update this map, because when a particular lemming starts to dig, you give it the digging behavior. What it starts to do is it starts to do its little cute little animation to dig into the ground. What we need to do is we need to add in a gap to that bitmap. So as I started to create this functionality and port over all this logic, I needed an easy way of seeing what my bitmap looked like, what my map looked. So I created a screen that just took that big long string and just made an SVG out of it. And so this screen then became my way of debugging what I was doing, because as soon as I started digging, what I had to do is I had to update that string by grabbing all of the data up to a certain point you're digging, and then add in the hole, so add in some zeros because you're creating a gap in the map, and then go and add in all of the rest of that map. I applied some optimizations to this so that when the animation starts for digging, you would add in a number of holes, so you'd queue up a number of holes, and then in the game loop, it would take those holes and apply them to the map, so that you would then in one operation concatenate all of the parts of the map that remain with the zeros from the holes that you're applying. And again, I found that was actually surprisingly performant, because I was a bit worried that that wasn't going to be very performant at all. The next thing I needed to do with that is, well, how do we have not only the map being updated so that when the lemmings walk along, they will fall down that gap, because it's great, having this functionality. The map itself, the image itself is not being updated. So it just looks like they're falling through rock, because as far as the player is concerned, there's nothing happened. I needed to work out some way of creating a hole that's visible to the user. I could find no way of easily creating a change, a material change to an image that's going to be quick, that's going to be part of the actual Power FX itself. What I decided to do is to say, okay, well, actually what we can do here is we can have a layer. So we can have the map, which is the standard image behind. And then on top of that, in the same way as I'd already done all of that work trying to create a performant SVG rendering of lemmings, I kind of reused that work with the SVG control to say, okay, well, actually what I'll do here is just iterate over all of the holes that I've created. And they could be just dig holes, the rectangles, but they could also be holes that have been created from an explosion, because when a lemming explodes, it kind of leaves a dent in the land. And so it iterates over all of those different shapes and plots them into an SVG control, and the rest of it is transparent. And so what happens is that when you layer those together, what you end up with is a layer on top that then masks that image below. It ends up being effectively, exactly as far as the user is concerned, that the image has been changed. If I needed to have some background, then I would probably need to make the image, the background image, an SVG as well, and start to do some more complex SVG manipulation using masks and things like that. I had all of the basics. I had all of the functionality that I needed as building blocks to add the rest of the game in. So as well as holes, I added the ability to create the blocks that the lemmings can apply, and it worked exactly the same way. Rather than just simply plotting a black rectangle, I would plot a white rectangle for the block that the lemming is applying. It would be the same idea. As the lemming animation was happening, the actual blocks would be a collection that would be added to, and then at the end of the game loop, the code will apply all of those blocks, simply just, create that SVG, a big long string that gets rendered. And of course, the SVG only gets changed when the collections that it's bound to is updated. And that's one of the great things about PowerFX, is that you have this subscription to observables. So the SVG isn't constantly refreshing. It's only refreshing every time the collection for the holes all the bricks gets changed. So then I started to add all the other different skills, climbing, explosions, the falling, and then when they fall too far, they will die. That's probably why it was called Lemmings. You know, lots of lemmings walking off a cliff and dying. That's the stereotype of a lemming. I'm not sure actually lemmings really do that in the wild. And then adding functionality for being able to nuke them all, you know, so they all explode, the ability to add an umbrella so that they can float down. And so it was just about applying that functionality using the same pattern. And then the ability to be able to pan left and right on the different maps, because each different level could actually have quite a long map. So the first one is just on a single screen, but later levels actually had much longer maps. So I had to have the ability to have a slider to move back and forwards. And then I added the screen to be able to select the level. And each level was an initialization of not only the image to use, but also the starting position of the lemming, the finishing positions of the exit of the lemmings, and how many lemmings were being released, the rate that they were being released, and also, of course, that critical bitmap of the image so that we can detect where the different ground is. That was it. I was pretty pleased, and it became somewhat of a passion project of mine, just adding these skills. Each time I would just grab a few more hours and just added an additional piece of functionality. It's by no means complete. I mean, I've only got 4 levels in there. I haven't implemented the animation, for example, when it falls into water, the little lemming would sort of float away. I haven't done that. There's more work I could do, but I think I got to the point where I proved that PowerFX could actually do this. Now, do you write games with PowerFX? Probably not, but I think this kind of exercise is very, very useful for understanding how a language works to a much, much deeper level than perhaps you would get if you were just doing just a standard application. Sometimes having a much more fundamental lower level understanding of a language does mean that when you do get hit by a particular strange problem with an app that you're building professionally, it gives you a lot more insight in the ability to actually debug that. I think that's what it's done for me. Well, there you have it. I hope you found that enjoyable. Maybe it given you some ideas for the apps that you're going to be building, professional apps or games. Either way, I would love to hear from you. Thank you ever so much for watching, and until next time, cheers.